Okay, I'm going to look at procedures now. I'm going to break with what I've been doing throughout this series, and what I'm going to do is actually just extend my design here. So this time I'm going to have a procedure which is going to be dedicated to just printing the person's name out. So first of all, let's delete this and move this symbol down. I'm going to have another subroutine. Okay. Now the point of subroutines is that they just do one job and one job only, or should. They'll probably have lots of lines of code, but basically they just do one job. The job of this one is just to get a person's name from the keyboard. And the job of this one is just going to be to print the person's name on the screen. So I'm going to call it show name. So there's now my main program where I've got a function, get the name, and I've got a procedure, show name. Generally we can tell whether we've got a function or procedure by the word that we use in front. So if I use the word get, I tend to want it to be a function, so it returns something. And if I use the show or print, then it's not going to return anything. It's just going to do a job and not return anything. So I've got yet another little piece of programming to do here because I've got another subroutine. So let's just do that now. So Terminator, and this time I'm going to have the name of the procedure on it, show name. And then I'm going to have my output box, and finally a Terminator. So here I'm going to write output name, and here, oops, and on this one, see, I've made a mistake. I forgot to put the word end, and end there. So now I can join these together. So what I want you to notice now is that I've got three ends. So I've got three very separate programs. Only the main program has the word start. The function here has the function name, and the procedure here has the procedure name. We can't see any difference between them. It's got input, it's got output, that's the only difference. It doesn't tell us whether it's returning a value or what. However, in our pseudocode and our program, it will do that. So let's go back to our pseudocode, and I'm going to do this second one, show name. So this time I've got a procedure, and it's called show name. And actually it's going to take something called the parameter this time. I didn't use the parameter last time. These are called parameters, or when we're in the functions they're called arguments. So to be honest, I should call this an argument, but it doesn't matter which way round you call them at the moment. What I'm going to do is put name in there. So there's one difference, but that doesn't define functions and procedures, because I could put something in there like message, and instead of having input please enter your name, I could have input message. So I could pass values in to my functions as well as procedures. There's no difference. So all I need to do now is print name, and then end procedure. There is no return statement. There should never be a return statement in a procedure. It just does one job and doesn't give anything back. So now I've mapped my procedure here and my function in pseudocode. My main program would now change a little bit. So I've got my name equals get name, so I've run this function, but then I want to show it on the screen, so I would have show name my name. And there's the difference between the function and a procedure. The function has an equal sign in the call. There is no equal sign in the procedure. That is a big difference. So it's useful showing them side by side. Let's hop over to Python and see that operating. So I now need to write my procedure, and in Python it's exactly the same keywords as for the function as procedure, but not in all languages. They can change, and in some languages they're also called methods, particularly Java, so we have to be careful how we or what we call things. So this one is show name, and it takes a variable name, and we have a colon at the end, and that is called our function header, or our procedure header, function header. And all we're going to do is print name. So I've actually taken that out of there, and that's it. There's my procedure. There is no return statement in a procedure. So how can I use that? So instead of having print name, so I've run my function here, my name equals get name. Here I need to call show name, so I just call show name. So this really is matching the pseudocode 100%. My name, it has to be that variable. That's the variable in the main part of the program, okay, which if you can see here, they're all separate. So in here I call it my name, here I call it name, here I call it name. In fact, let's just change that to a variable called person, print person, so we can see that the variables have different names in each of the functions and procedures and the main part. So show name, my name, so it's going to pass in my name here, so that person or that word variable person is going to equal whatever I typed in at the keyboard, and then it's going to print it out. So if I run my program now, it's going to do exactly the same job as before. Please enter your name, Eric, and there you go, it prints Eric out for me. So that is procedures and functions. You need to know the differences for the exam. You need to know how to sort of write them out in pseudocode, knowing that you're going to be using a procedure and a function keyword in each, and that you're going to have an end function and an end procedure. You need to know that the function call has an equal sign, but the procedure call does not have any equal sign in it. And I think you need to be aware that in different languages they work differently. As we're programming in Python, there's very little to distinguish between these two in the header of the subroutine, but there definitely is a return which makes it a function, no return which makes it a procedure. And that is the crux of it. As we will be going along in our programming venture, I'm going to be introducing quite a lot of different styles and information that will not be tested by the exam board, but from my point of view it's good design practice, and it's going to be useful to pass on to other programmers. I'm just going to finish with this statement. If we were working in a group, so it's 3 or 4 of you working on one program, one person might be responsible for writing a procedure or a function, whereas another person might be responsible for writing a different one. So you're all splitting up the job of writing the program. and there'll be one person who's writing the main part of the program. And by doing this, we can sort of allocate different tasks to everybody, and the person who's writing the main program can actually include all of these functions in. So let's say I was going to do yet another one, def multiply by 5, and I've given that to another person to program. Whilst I'm waiting for them to program it, I can use the keyword in Python only as pass. In other languages it just be blank, but in Python we use the keyword pass. And what I mean there is that I want it in my program, but the person hasn't written it yet, so I've just used the word pass. But I can call that in my program, so I can just do multiply by 5 as a call, and my program won't crash. It will accept the fact that there's some code going to be given later, but it won't crash or burn. So when I run it, it's going to be okay. It's going to ask for a name, Don. It's going to print Don, but I've not got a crash. And that way I can sort of map out my program from start to finish and just wait for the people to actually complete their code and give it to me. So this is called modular programming, and it is the way that it is done. So lots of people work on one program, and they're given tasks to do, which may be just functions or procedures. It's a very, very useful, very, very powerful method in programming. So that's subroutines.